Hello! So if you watched last week's Sudoku video, you'll know two things. First of all, that I've had an awful lot of hair professionally removed since last week. Hope you like the new style. And secondly, that I am very excited to present this rule set to you. As far as I'm aware, it's an original rule set. That said, my knowledge of Sudoku rule sets comes entirely from the Cracking the Cryptic YouTube channel, which is very much the tip of the iceberg when it comes to the Sudoku community. Nevertheless, whether it's original or not, I think it's great fun. I think it's got a lot of potential, not unlimited potential, which I will discuss as the video goes on, but a decent amount of potential. Anyway, I found 5 Sudoku settings with it, with slight variations on the rules. So what I'm going to do is I'm first of all going to explain the rules to you, and all 5 of those Sudokus, and the slight variations in rules. And then on the 5th Sudoku, which is actually the first Sudoku that I made with this rule set, it's not such a smooth solution path because I wasn't quite used to the rule set yet. I hadn't worked out nice things that I could do to help with the solution path, so it's a little bit scrappy in terms of the solution. So what I'm going to do is I'm going to use that one as an opportunity to talk about some of the implications of the rule set in general terms, and then I'll give some vague tips about how to solve that particular Sudoku. But I wouldn't recommend solving that one first. So I would just have a listen to that kind of not full solution but vague walkthrough, and then after that I will present this Sudoku and one of the others, which are two slightly different rule sets or slightly different variations on the same rules, and then I will leave the other two to you to have a go at if you would like to, and then at some point in the near future I will present full solution videos to those as well. So what is this rule set? Well, first of all, normal Sudoku rules apply. That is not the original part of the rule set. That just means that every row, column and 3x3 box must include the digits 1 to 9 exactly once each. Right, here we go. Draw a train. That's not very good highlighting. Draw a train of orthogonally connected non-looping cells that can touch itself diagonally but not orthogonally. So if you've ever done a kind of snake puzzle before, you'll know what I mean by this. It can touch like that at a diagonal, with the corners touching, but it cannot touch like that with an orthogonal edge touching. And yes, so it's a fairly standard snake, if you like, in that sense. Its carriages are 2-cell killer cages. The first carriage sums to 3, and thereafter each carriage's sum increases by 1 until the last carriage, which sums to 17. So let's say our train is something like that, for example. What that means is that this is the first carriage on the train. It's a 2-cell killer cage. That means that both of its digits add up to 3, and then the next two would add up to 4, and then those would add up to 5 and 6 and 7 and so on, all the way up to 17 at the other end. Or maybe it's the other way around. Maybe this end is the 17 and 16, 15, 14, all the way down to 3 at the other end. And that's the train. Yeah, there's nothing more to say on that. That is the rule set. That's what all of these Sudokus have in common. That's the theme of today's video. Good, alright, so let's clear that. Circled cells. Now this is the bit that's slightly different from a couple of the other Sudokus. There's a slight variation going on here. Circled cells are not on the train. A circled digit shows how many train cells neighbour that circle orthogonally and diagonally. So what that means is when you're drawing your train, you've got to make sure that, let's say it's that, exactly 2 of the cells that surround this 2 clue are in the train. So here we've satisfied the 2 clue because there are 2 train cells neighbouring that 2. it's a little bit of an awkward one to word. It's not orthogonally and diagonally in the sense that we need two diagonally and also two orthogonally to be in the train. Yeah, it's what you think it means. Sometimes it's quite difficult to word the rules precisely. It does need to be absolutely exact, and I'm aware of that, so hopefully that clarifies that. It just means that 2 of those surrounding 8 cells are in the train, and 3 of those are in the train, and so on and so forth. Good. And that's it for this one. That's all the rules you need to firstly draw the train, and secondly use the information about the train and all of the killer cages along the train to complete the Sudoku. Alright, the next one is exactly the same. You'll notice that some of these circles are empty. That just means that you need to find out what digit goes into those, and then from working out what digit goes into them, let's say that's a 5, then maybe you can work out that the train does something like that, for example. Or maybe you find out that the train does that first, and then from that information you say that that's a 5. That's not a 5, but you know what I mean. Good. So otherwise it's exactly the same rule set as the first one. That is not necessarily a 5, so let's take that out. Right, the third one has a slightly different rule set. We have squared cells rather than circled cells here. The train is exactly the same, so again we need to draw a train of orthogonally connected non-looping cells, etc. The carriages sum to 3, 4, 5, 6 and all the way up to 17. Square cells are not on the train. That's the same as the circled cells. A squared digit x indicates that there are x cells on the train in either the same row or the same column as that square, or both. For example, the 4 in row 3 column 2 indicates either that there are 4 train cells in row 3 or that there are 4 train cells in column 2. If the former is true, let's say there's 1 there, 2 there and another 1 there, then the clue is satisfied, and that clue is finished, and there can now be any number of train cells in the column. It doesn't matter. There could be 0, there could be 4 again, or there could be anything in between or above. So as long as it's satisfied in the row or in the column, then the other one out of row or column doesn't matter. That's just to clear up a little bit of potential ambiguity. If you interpret that as well, there's 2 there and also there's 2 in the column, and so that clue is satisfied because there's 4 in total. It's not that. It has to be 4 in the row or 4 in the column, and as long as it's one of those 2, then the other cells can be whatever they like, train cells or not. Good, and that's the rules for this one. Again, we've got some blank cells. They are for you to fill in, or to fill in first and then work out how many train cells go around them based on that, or not around them, but in the column or row, or potentially you might find out how many go around them and then be able to fill in the digit from there. Good. This one is called Ash's Training. It's the only one that isn't called Killer on the Orient Express. I was quite pleased with the title Killer on the Orient Express. It's certainly not my worst. As for Ash's Training, you'll see why it's called, maybe you'll see why it's called Ash's Training when I get round to this solve. This one, exactly the same again. It's the rows and columns variant as opposed to the neighbours variant. So that this just means that there are 4 train cells, 4 cells that are on the train, either in the column or 4 train cells in the row. And as long as one of those 2 is satisfied, then the other one doesn't matter. And that's those rules. Right, so let's have a look at this 5th one. So like I said, this is the first one that I created, the first Sudoku that I created with this rule set. So it's certainly worth putting out into the public domain. I just don't think it's the smoothest solution path for a couple of reasons. And it's not the smoothest rule set for a couple of reasons either. Partly because in order to make it humanly solvable, I needed to add a couple of extra rules. The first of which is that this is one of the ends of the train. So unfortunately, I do have to give that information straight off the bat. So that's given. I don't say which end of the train it is. That's up to you to find out, and then obviously the other end of the train is up to you to find out as well. And there is one other rule that unfortunately I had to add because there was a deadly pattern at the end, which couldn't be resolved by normal means. So I added in this rule: in the finished grid there is one digit not on the train that is equal to the number of train cells in its row multiplied by the number of train cells in its column. So it's still kind of thematic, but it's just annoying to have to add in an extra paragraph in the rules just to disambiguate between a couple of different options at the end. But anyway, those are the rules. So it's not the most clean version of this rule set that I've created, but it's a good start, I think. Alright, so like I said, what I'm going to do is I'm going to use this Sudoku as an opportunity to discuss a few of the general properties of the train that we are going to have to draw in all 5 of the Sudokus, and then using those general properties we'll go back onto the others, one of each of the different types, and I'll walk through the solutions to those. Okay, so before we look at this specific setting of the Sudoku, let's talk about the train. The first thing that you may already have worked out is that there are going to be exactly 30 cells on the train, because we have a killer cage that sums to 3, then 4, then 5, all the way up to 17. That's 15 different killer cages, each 2 cells long, so the whole train in total will have to be 30 cells long. And we can actually go a little bit further than that. What I'm going to do as quickly as I can is turn this Sudoku grid into a chessboard, and I will explain why as soon as I've finished it. Here we go. That wasn't too long. There we go. So I've turned this into a checkered pattern. Now we know that this is one of the ends of the train. So let's not colour it for now. This is one of the ends of the train, so that's going to be, let's say it's the low end. It's going to be one of the ends of the 3 cage. So then the other end of the 3 cage is going to be in a black square. Wherever it comes out, it's going to be on a black square. And then the 4 cage will start on a white square. Wherever it is, it will have to start on a white square. And then it will have to end on a black square. And then the next cage, the 5 cage, wherever it starts, it will have to be a white square. And then it will finish on a black square. And so on. And you can see where this is going. The kind of parity of the square, or the black or whiteness of the square, at one end is going to be, well, at one end it's going to be white, and then at the other end, once we've added in all of the 2-cell killer cages, let's say it goes down here, for example, eventually we will get to the 17 cage and it will end on a black square. So what does that mean? It just means that we know that the 2 ends of the train will have to be on opposite kind of square parities. We won't be able to get from one end of the train to the other end of the train with any number of bishop moves in chess, is another way to think about it. So that's a useful piece of information. Once we know the square parity of one end, then we can use that information to work out the other end and vice versa. Alright, I'm going to get rid of that for now. And another property is specifically to do with the ends, and this is why I mentioned earlier that the possibilities with this rule set are a little bit limited. So again, let's pretend that this is the low end. Well, the low end is going to be a 3 killer cage. A 2-cell killer cage that adds up to 3. Now, if you've done any killer Sudoku, you'll know instantly that that has to be 1 and 2. There's no other way of using two different Sudoku digits to sum up to 3. Then the next one, the next killer carriage, whatever we want to call it, is going to add up to 4. And again, if you've done any killer Sudoku, the only way to make 4 with 2 different digits of a Sudoku is 1 and 3. Now, do you notice an issue here? Yes, we've got 2 1s in the same column. So what that means is that we can never have the last 4 cells of the train all in the same, did I say column? I mean row, or column, in fact, or box. There's no way we could do it. We couldn't have it ending here and having that as the 3 cage and then the 4 cage being over here like that, because then they see each other in the same box, and we have a clash of 1s. So that can't happen. But we can actually go a little bit further than that, because let's say we save it by turning the corner, which means that these two can both be 1s. Then we get a 3 there and a 2 here. Well, or maybe that could be the 1 and that could be the 2, for example. That would still be fine. Can we put the 5 carriage in this same box? Well, no, we can't. We can't do this for the train because this is 1, 2, 3, 4 cells adding up to 4 plus 5, that's 9, and we can never have 4 different digits of a Sudoku adding up to 9. It just can't happen. We can't make this 2 and 3 because of the 3 there. We can't make it 1 and 4 because of the 1 there. So again, we're going to have to do some dodging around to make sure that we can kind of escape this bit and get an extra digit in here. You can kind of go a bit further than that, and you can say that the 5 carriage and the 6 and the 7 carriage can never be in the same box. So we could never have the train going like this, or the same column or row, of course, with that being the 5 carriage, that 6 and that 7, because 5 plus 6 plus 7 is 18, but 6 different digits in a Sudoku must add up to at least 1 plus 2 plus 3 plus 4 plus 5 plus 6, which is 21, so that doesn't work. So there are quite a lot of restrictions with the ends of the train. Now obviously, not necessarily obviously, but the same applies at the other end of the train. So if we replace this with 8 and 9 and 7 and 9, a 2-cell killer cage that adds up to 17 must include an 8 and a 9. That's the only way of doing it, and the only way to make 16 is a 7 and a 9. So again, we need to turn this corner to make sure that the 9s don't clash. Basically everything I said about all of the low numbers applies exactly the same, but kind of symmetrically opposite to the high numbers. So those are some restrictions that we can put on the ends of the train. Good. Okay. So let's just have a quick walk through what happens in this Sudoku. Okay. The first thing to notice is this 6. This 6 is probably the most eye-catching clue within the Sudoku. There are only 5... let's rule out the row first. Can the 6 be referring to the row? Can the 6 be telling us that there are 6 train cells in the row? Well, we know that square cells are not on the train, so those are out. In fact, let's do that now. Let's colour these all grey. That didn't really do much, did it, because of the square tool, but anyway. So that leaves 5 candidates for train cells in the row. So no, it's not going to, the 6 is not going to be referring to the row. It must mean that there are 6 train cells in the column. Can we fit them all in there? Well, no, because that's only 5, so it must go down into this region by at least 1. Maybe it comes in and ends there, or something like that, or comes in and ends there. Okay, so let's investigate those possibilities. We know that that's one end of the train, so we know that the other end can't be on the same kind of bishop parity as it. So it can't end here or here. So if it is going to end here, if all 5 of those are in and it ends in here, then it has to be here that it ends, because that's the opposite parity, kind of cell parity to this one. So we know that this therefore must be in. But of course it can't just end there without either of those two being in, so we know at least one of those two is in. Can it be that one and not that one? Well, in that case it ends in this cell and it comes out, say, like that. But then what happens? We have the last 4 cells of the train all in the same box, and there's no way we can ever do that, because we can't have a 9 and an 8 and a 9 and a 7 in the same box, and same with 1 and 2 and 1 and 3. So it must come out this way, at least this far. In fact, it must just come out this way. It can't stop in here. There's no way it's going to end like that, for example, because then the last 6 cells on the train will all be in the same box. So it definitely does come out like that. Right. Then we can ask, what does this 2 refer to? Does it refer to the column or the row? Well, if it refers to the column, then there's no way we can kind of dip in and out again, only using two cells, because then we'll touch the train orthogonally. That's not allowed. So we'd need at least 3 if we were going to dip in and back out again of this column. So if this 2 is referring to the column, it must be referring to the end of a column. It must be ending here, for example, and just having 2 train cells in the column. Okay, well, if it's ending in this column, if it's ending in this column, where is it going to end? Well, it's going to end on the opposite parity of cell to this, so it can't be any of those. Those are all ruled out, so it must be one of those. Obviously, it's not there because square cells are not on the train. It's not there because that would make the train a looping train, and it's a non-looping train. If it's here and it comes out this way, then however we do it, it's going to end up with 4 cells in the same box at the end of the train, and that's not allowed. And if it comes out this way, then it's going to touch the other end of the train orthogonally. So it would have to be here that the train ends, and it can't come out that way, obviously, so it would have to come out this way. And then in order to stop having the last 4 cells within the same box, it would have to come out this way and go off and do some other things. So that is a possibility for the 2 being a column clue rather than a row clue. Okay, it's at this point where I am going to speed up and not give you all of the answers step by step for this Sudoku. What I'm going to say is I'll just explain that you go through a little bit of trial and error, which is a little bit unfortunate, but I did say that this was a kind of scrappy solve, but we go through a bit of trial and error to explore whether this arrangement is possible, and basically you work out that it's not. We would have to go something like this, and that is exactly 30 cells. I think if you go through and count that, that's exactly 30 cells. And we can do things like that to alter the path slightly, but it still has to be as direct as possible. And that means that there's no way we're going to satisfy this 6, for example. That's just not going to work. So with a little bit of trial and error, you can prove that this does not work. So the 2 does not refer to the column, therefore it must refer to the row. And once you know that it refers to the row, then we can say that, well, there's one end over here, and it dips down below this row once, so it must come back up above the row. So the other end must be above the row, so it can't be there. So it does indeed carry on out here. What we can also say, and this is another important technique for helping you through the other puzzles, is that because we now know that this is a row clue, I'm going to use red for row, and I think yellow for column is the one that I've been using over the last week or so. Red for row. This can't be referring to the row anymore. If we know that there are exactly 2 train cells in the row, obviously there aren't 4 train cells in the row. So this must be referring to the column, and this must be referring to the column. And actually we already knew that this was referring to the column. So that means that because this one is referring to the column, that one can't be referring to the column anymore. It must be referring to the row. Right, and then what else can we do? There is a way of working out the other 3 clues and which way they're referring to, which ones they're referring to. This 3 we can work out straight away. It's already got 4 clues in the column, so there's no way it's going to be a column clue. It has to be a row clue. So that's telling us that there are exactly 3 train cells in this row. We've already got 1, so we need 2 more. Oh yes, this 5 clue in conjunction with the 3 clue. Well, because we only got 2 more train cells in the row, it can't go up and down and back up again. It's got to kind of do an S-bend into the next row up. And similarly, this 5, it can't come up and then back down and back up again. It's just not going to work because we can only have 3 more cells within the row because we've already got 2 and we need to have 5 train cells in the row. So what we end up getting is that it's either going to be a little S-bend there and a big S-bend there. Well, no, because it hits a dead end. A little S-bend there and a big S-bend there. That's a possibility. Or it extends out to here, have a little S-bend there and a big S-bend there, and then it carries on. And so those are our 2 options. So we can pretty much grey out everything that I didn't just highlight as a possible option. I think that's all of these cells. So it can do that, yeah. So all of those are greyed out. And that gives you more information about where the train can go. And eventually you do fill in all of the ends based on the information you have from the clues you're given. You fill in the whole train, and once you've filled in the whole train, to be honest, it gets very easy once you've filled in the whole train because, as I already explained, it's a very restrictive rule set at the ends of each train with the how the digits are forced in, the low digits are forced in, and the high digits are forced into the high end of the train. So it solves itself pretty quickly once you've got through actually placing the train. But anyway, I think it's good fun, and I quite like that it solves itself quite quickly. Like, it's nice to have rule sets and puzzles where you're still using the cryptic elements of the rule set right up until the very end. I do quite like that, but also it's also nice when you've done the cryptic bit, you've done all the hard work, and now you can just enjoy a nice, easy, classic Sudoku for the rest of the solve. So I don't know, whatever floats your boat, but I quite like it. So yes, I will leave you to finish the rest of this solution if you like. I'll just mention right at the end, in the finished grid, there is 1 digit not on the train that is equal to the number of train cells in its row multiplied by the number of train cells in its column. Quick spoiler alert, skip over the next minute if you don't want the answer to this bit. Basically, the idea is that you have to go through every digit in the grid to double check that it does not fit this property. And then, actually, I suppose this isn't really a spoiler. If you find that there is a digit in the grid that does fit that property, because by this point you'll have already finished the whole train and most of the digits of the grid, all but 7, I think. If you find that there are none that fit that property, then you will need to make sure that you fill in the final deadly pattern in such a way that you create one, And if you find that there is one already, you'll need to fill in the deadly pattern at the end in such a way that there is not that none of those from the deadly pattern are that fit the property. So that's the that's the idea. It's a little bit laborious. Maybe it's a bit mean. Maybe I could have just done an inequality sign or something just to disambiguate the last couple of digits. But no, I thought I'd go with something a bit more thematic. Anyway, that's that one, and a couple of general properties about the trains themselves. So let's use some of that knowledge and information to go through a full solution to this one. Now let's just switch back into the other variation of the rule set now, which I think is slightly easier to get your head around. In this rule set, each circled cell describes how many train cells are in the neighbouring 8 cells, or in the case of this one, it's only 5 cells that are neighbouring. So one of those 5 cells is on the train. Okay. Yes, do have a go in the description if you like. I'd be very interested to hear how you get on. If you're struggling, that's absolutely fine. Just have a listen to the kind of bits of logic to use in this Sudoku style and have another go. All right, so here we go. The first place is actually this one. That's the first thing to look at. And the question to ask is, can it be here? Can this be the one neighbouring cell to this clue that is in the train? Well, let's write it in and see what happens when we do that. It can't be here, so it's going to have to come out this way. It's got to be an end as well. It can't carry on at all. So that would have to be an end, which means that we couldn't have that. We couldn't have that because that would be 4 cells in a row at the end of the train, and that causes a clash with either 1s or 9s. Obviously, it would never be 1s over here, but yes, that would cause a clash. So it can't be that. Instead, it would have to be that. And as soon as we do that, the 4 is satisfied. They're all done. So we can colour all of these in red. In fact, we can colour these in red anyway. No, I'll be consistent. I'll use grey. The only reason I would use red for this one is because we don't need to have a kind of red tinge and a yellow tinge to indicate column or row, because these don't have column or row properties. They're just neighbours. But yeah, we'll be consistent. We'll use grey. So yes, as soon as we've filled in those 4, then that 4 is satisfied. So all of its remaining neighbouring digits are done. Now, in order to satisfy this 3, we need this to be in. Yes, we need this to be in because, well, the 1 is satisfied, so we can block those all off. And in order to finish off this 3, that needs to be in. Is that possible? Well, again, that would have to be an end. It would have to come out like that, and that would break the 3. And in addition, one of these ends would have to be the low end, and would have to be a 1-2 pair, and this 1 sees all of it. Basically, it's not going to work. So that was all based on the premise. Oh, I've undone all of my colouring there. That was all based on the premise that that is in, so it's not. Let's just go through again and re-grey all of our clues. Okay, so can it be this one? Well, no, because it would have to come out through another one of the 1's neighbouring cells, so that's not going to work. So that's not in. Can it be this one? Well, if it comes out like that, then it's going to have 4 cells at the end of the train seeing each other, so that's not allowed. And if it comes out like that, again, they all see each other because they're all in the same box, so that's not going to work. It has to be this one, and it comes out like that. Now, if it goes round this way, then that's going to be overkill on this 3, so it has to come out this way, and then that 3 is finished. So those are all done. We can't have any more for this 3. Now it has to come down then in order to escape, and now this 3 is finished, so those are all done. So it has to come out this way. Good. Now these, this 4, well, it's only got 3 more spaces left for train cells, so all 3 of those have to be on the train. Can this be an end? Well, no, because then it would have to come out like that, and all 4 of the end cells on the train would see each other, so that's not going to work. So it does have to carry on. Oh, it could carry on like that, couldn't it? And then this could come down like that, I think. Well, either way, this definitely carries on like that. Okay, let's have a think about this 7. There's probably something really obvious that I'm forgetting to say whether that's in or not, but anyway, let's have a look at this 7. There are only 8 cells here, so 7 of them must be on the train. Can they be those 7? Well, no, because we've got a branch over here and we've got an end. Well, we've got 2 ends. It's just not going to work. Can it be those 7? Again, no, we'll have an end in the corner, and that's just not allowed. Can it be those 7? No, again, we'll have an end over here. So it's got to be those 7, or those 7, or those 7. It can't be that either, because again we have an end here, and the last 7. Oh, well, we have a branch there as well, but yeah, the last 7 cells on the train all see each other, and yeah, that's not allowed. I'm just going to mute my laptop in case you can hear those notifications that are buzzing away. Okay, so it's going to be either this, or this. Okay, well, it's not going to be that or that, because those both cause branches. It's this, basically. Pretty straightforward. It's got to be that. So now, because we know it doesn't touch itself orthogonally, those are out, and it doesn't loop, so that's out. So it does, in fact, have to come out like that. So that's the way to prove it. These are also out because it doesn't touch itself orthogonally. It has to escape this way. It can't touch itself orthogonally, so that's out. It can't touch itself orthogonally, so that's out. It has to escape this way. We're making good progress on the train. It's good stuff. However, that is more or less where the progress stops for now. Let's start writing in some digits. Is this the high end or the low end? Well, obviously it's not a 1-2 pair, so it must be the high end. It must be a 2-cell carriage adding up to 17, so it must be 8 and 9. This adds up to 16, so it must be 7 and 9, but because there's a 9 already there, that must be the 7, that must be the 9. These are 2 cells adding up to 15, but they can't be 9 and 6, so they must be 7 and 8. These are 2 cells adding up to 14. They could still be 5 and 9 or 6 and 8. These add up to 13. They can't be 4 and 9, so they are either 5 and 8 or 6 and 7. But if they're 5 and 8, then that stops this 14 from being 5 and 9 and 6 and 8. So that's not going to happen. It must be 6 and 7. And now we know that. This can't be 6 and 8 anymore, so it must be 5 and 9. These two add up to 12, and they are not 7 and 5, but they could still be 8 and 4 or 3 and 9. These add up to 11, these add up to 10, these add up to 9. Not too much information on those until we treat them all as 1, because 12 plus 11 plus 10, that's 33, plus another 7, that's 40. I thought there was something clever to do here, and I'll find it in a second. Anyway, here we go. So, oh yes, okay. So those add up to 40, and because we know that all 9 cells in a 3x3 box add up to 45, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 equals 45, and those add up to 40, those two must therefore add up to 5, so they must be 1, 2, 3 and 4. Well, a 1 and a 4 or a 2 and a 3, but that is not a 3 or a 4, so it's a 1 or a 2, so that can't be a 1 or a 2, it must match that, so it must be a 3 or a 4. Okay, we know that that and that adds up to 9, so that is a 5 or a 6, it could be a 4, 5 or 3, 6. Right, rather embarrassingly, I've managed to get stuck on my own Sudoku. I've sorted it out now, but a little bit of post-editing is required to pretend that it was all fine. Um, it's not quite all fine because this version of the Sudoku is one where I've actually taken out one of the clues, which I thought was completely redundant. And the main reason I put it in the first place, that reason is not a good reason, by which I mean it's not needed for that reason. But it is helpful for a reason that I didn't realise, and what I should have done is gone through and double checked the full solution to make sure that it still all works. There is still, I think, a way to proceed anyway, so we're going to have a go because, quite frankly, I want to post this video by midnight, and we're closing down on midnight, and I haven't even started the other solution yet to the other puzzle. So yes, we'll keep plodding away with this with a slightly different solution technique. But what I'll do is I'll put in a note at the very bottom of the description, giving an extra clue, which should be back in there really. One that I took out that will help make one of the steps of this slightly less scrappy. Anyway, for this step, we look at the nines. This is not the scrappy step yet. There is an X-wing on nines, which means that there is either a 9 there and there, or there and there. Either way, there's definitely a 9 up there. So it's either part of this 12 carriage or this 11 carriage. If it's part of the 12 carriage, then it's paired up with a 3, and if it's part of the 11 carriage, then it's paired up with a 2. Either way, it's definitely paired up with a 3 or 2, so this kind of virtual 5 carriage here cannot be a 2, 3 anymore, so it must be 1 and 4, and from there we can get that the 10 carriage can't be 1 and 9, 4 or 6, or 3 and 7, so it must be 2 and 8. Actually, we can get this 9 carriage straight away, obviously, because 4 plus 5 equals 9. This 11 carriage, the even number that is required in the 11, cannot be a 4, 2 or 8, so it must be a 6, along with a 5. This 6 tells us that there is a 6 there and a 5 there, and this is indeed the 3, 9. There's actually quite a lot of normal Sudoku we can do in the top 3 rows now. This 2, 8 tells us that that has to be the 8, that's the 9, that becomes a 9, that becomes a 5. Those 2 5s tell us that that's a 5. What else do we know? Along the top row, we need a 2, 4 and an 8, and that 8 tells us that's an 8. That's a 2, 4, and that becomes a 6. We need a 1, 2 and 3, and that 2 tells us that's there, and that's a 1, 3 pair. Now this is the scrappy bit. I'm not going to tell you here what the extra clue should be. I'm just going to... I'm not entirely confident in this solution path, to be honest, but just by means of, unfortunately, trial and error, can we visit this 2 before we visit the 4? If we visit the 2 first, it's going to have to be something like that, which is the right number of cells. So this would be an 8 carriage, 7, 6, 5, 4, 3. So that works in terms of the length, but let's fill that in. That would be a 1, 2 pair. That 2 tells us that's a 1, and that would be a 2. Let's fill that in. Then this would be 2 digits adding up to 4, so they must be 1 and 3. Then these would have to add up to 5, and the minimum that can be is, well, it can't be 1, 2, 3, 4 or 5 now, so it would have to be a 6 and a -1, and that's not going to happen. So, and I think that's the only way to visit the 2 first and then the 4 in such a way that the 2 and the 4 are both satisfied. So it's going to have to visit the 4 first and then the 2. What else do we know about the 4? Well, it can't go round the back of the 4 because then it's going to be at least 5. And it can't end here either because then that would be 4 cells within the same box at the end of the train, and that's not allowed. So it's going to have to come out this way. So we could either do something like that. So 8, 7, 6, 5, 4, 3. is not going to work because the last 4 all see each other. Even if we do something like that, that's not going to work still because the last 4 still see each other. Or it's going to be 8, 7, 6, 5, 4, 3, and that works. And that's about as direct as we can make it go, with everything satisfied and without the last 4 cells seeing each other. So it's not a particularly satisfying way to solve it. I think there is another way. Mind you, the other way is a lot less direct. I remember my solution the other way being a lot less direct than just doing a little bit of trial and error and immediately getting that that's the answer. I think that's the only way, with the information that we know at the moment. Obviously, I do know that this is the solution, but I think that is also something that you can know with the amount of information that we know now. So I don't think I've completely ruined it by taking that extra clue out. Good. Okay, we've recovered it. We're back on the right track. So let's, for completeness' sake, let's colour everything else grey. So this is our train now. This is a 1-2 pair. That 2 obviously tells us which way round. This is a 1-3 pair. That 1 tells us which way round, and in fact that 1 knocks a 1 into there and a 3 into there. This has to add up to 5 without using a 4, so it must be 2 and 3, and that tells us which way round. This adds up to 6 without using a 4 and a 2, so it must be a 1 and a 5, and that 5 tells us which way round. That adds up to 7 without using a 1 and a 6 or a 5 and a 2, so it must be a 4 and a 3. We don't yet know which way round. This adds up to 8 without using a 5 and a 3. Can it use a 2 and a 6? I think at the moment the answer is yes. So I'm going to come back to that, and that is something that the other clue would have helped with. So I might go back on my words and say that actually I have ruined everything. But we will see. There's plenty more we can do just yet before we panic too much. Let's look at this 8 and resolve that. That's nice and straightforward. What else do we need? Let's look in this box. This is 6, 7, 8 and 9, but that's not 6, that's not 7. These 2 add up to 8. So they're either 2 and 6 or 1 and 7. If they're 2 and 6, we'll come back to it. There's definitely a 1. Oh, in fact, there's definitely a 1 here or here. We know that much. What else do we know? No, I don't like doing corner marks. Let's just fill everything in. We need an 8 and an... Okay, right, here's something. We need an 8 and a 9 in this box, and it's not going to be part of the 8 carriage, or it's not going to be part of anything that's already filled in, and it's not part of that, so that is an 8-9 pair. So the rest is either a 2 and a 6 here, and a 1 and a 7 here, or the other way round. Okay, good, right, we've resolved it. That 7 tells us that the 7 needs to go there. So that needs to be a 1. This needs to be a 2-6 pair. That 6 tells us that it's that way round, and I think we're in the clear. This is now a 1 and a 4, but that 1 tells us that that's the 4, and that's the 1. Okay, good, right, we're fine. And I will now reveal that the extra clue that I've been panicking about for the last 5 minutes was a circle just here, an empty circle, but obviously it doesn't take too long to draw the train in at this stage, and so you quite quickly get to the conclusion that this has to be a 1 in order to fit the clue that it's in a circle. So yes, the 1 gets filled in quite early, and then because there's a 2 here, that means that can't be a 2, so the 2 in this row has to go along here, and that rules out a 2-6 from this 8 carriage much earlier on. So yes, that would have been a little bit helpful, but we managed without it. We're fine. We're all good. So the rest of it is just straightforward, normal Sudoku. So let's do it. We need a 3, 5, 6 and 9. The 3 has to go there. That's not a 5 or a 9, so that's a 6, and that's not a 9, so that's a 5. That's a 9. That 3 tells us that that's a 3 and that's a 4. Oh, let's just fill everything in. 2, 4, 5, 6, 7, and 8. But this is not 4, 7, or 6. So, whoops. So this is not 2, 5, or 8. That's not a 5. That's not an 8. Whoops. That's not an 8. That's not a 7. That's not a 6. That's about as much as we can do for now. Oh, this column. Oh, that's a 7. That's a 6. And this column needs an 8. No, it doesn't. It needs a 4. Better. Good. We need 5, 6, 7, 8, and 9 in here. The 7 and the 8 have to go in here in some order. And this is 5, 6, 9. But that's not a 5. Do we know any more? Surely we know a bit more. Oh, hang on. There's stuff we can do over here. That's a 2. That's an 8. Those aren't 8s. So that's a 7-9 pair. So those that's a 6-8 pair, but the 6 tells us which way round. That's a 6. That's an 8, 8, 9, 9, and a 3 that we could have got ages ago. This 8 knocks that into place. That 7 knocks those into place. Oh, that's now no longer a 6 or a 9, so it's a 5. That needs a 1, 2, and 3, but that's the 1, and that's the 3, and that's the 2. That puts a 5 there, so that's a 2-8 pair. What else do we need? This row needs 5, 6, 8, and 9, but those aren't 5, so that has to be the 5. The 8 has to go there, and that's not a 9, so it's a 6, so that's a 6, so that's a 9. This needs 4, 7, and 9. The 9 goes there, the 7 goes there, that's a 4, 6, that's a 4, 7, that's an 8, that's a 2, that's a 2, and that's a 4. And that's the Sudoku done, with a slight panic in the middle. Yeah, I think I was a little bit hasty taking that one clue out when I did, and not checking through that the solution is still manageable without it. But yes, I think that clue just made it a little bit too easy at the start to prove that the train had to come out like this. You know, it's nice just to have a little bit of extra required logic. It's not much more because that immediately breaks the 3, having 4 train cells neighbouring that 3. So it's not too much extra logic. But it's nice to make you think a little bit more before immediately drawing in how the train comes out from there. Good, so that is that one done. So the next one is the same rules with the neighbours, but I am confident, don't worry, I have tested this one. I did actually do this one with one of these clues, I won't say which one of these clues taken out, and I think I ended up having to add something else in. It was all a little bit funny and difficult, but I've added the original clue back in, so it's definitely doable now. I have been through it. It's good. It's clear for you to have a go at. But I will not for now. I'm instead going to skip ahead to this one, Ashes training. Now, at the time of recording, England have had 3 days of the Ashes test against Australia. If you're following the cricket, you may know that the first 2 days were, spoiler alert, pretty disastrous. But the third day was good enough that it makes me want to carry on staying up till ridiculous hours of the morning watching what's happening down under in Australia. So it's all good fun. Anyway, for now, enough cricket. Let's get back to the Sudoku. So remember, this is the rule set variant where the clues show how many train cells are in either the row or the column. It's not to do with neighbouring cells or anything like that. Hopefully I explained that in enough detail earlier, in quite a lot of detail earlier. I do hope you put YouTube onto 2 times speed to get through all of that. Right, okay, so let's have a look at this one. Well, rather hilariously, I've had to post-edit again. I went all confidently into this solution, and then within a few steps, I already struggled to prove a hypothesis. I'll show you what I mean in a minute. But first, let's have a look at this 7. What this 7 is telling us is that there are either that there are 7 train cells in the column, or that there are 7 train cells in the row. So if there are 7 train cells in the column, it has to be all 7 of these, because these two can't be train cells because they're both square cells. In fact, actually, let's do that first. Let's go through and colour all of these grey. And if it's not that, if it's the row, then all of these have got to be train cells because they can't be the grey cells. We don't know which one is which though. Now, my hypothesis that I just tried to prove before getting stuck is basically that whether it's the column like that or the row like that, it's going to have to go this side of the 7. So that side of the 7 for the row, or if it's for the column, it has to go round like that. It can't go this side of the 7. Now that bit's easy enough to prove if it's a column clue, because then we get stuck, and this end has nowhere to go, and the last 4 cells on the train, in fact the last 7 cells on the train, all see each other, and that breaks the train very easily. But with this way round, it's much harder to prove. We can't do that because again we get stuck, but we can come out of the box like that. We could have something like that in theory, and we could have something like the 1-2 pair there. Let's say this is the low end, then a 1-3 pair here. Obviously that won't work in this case. Okay, let's do it the other way around then. The 8-9 pair, the 7-9 pair here. Those would then add up to 15, but that can't be an 8 or a 9, so that would have to be a 7 or a 6, meaning that would have to be an 8 or 9, but it couldn't be a 9, so that would be an 8 and a 7. This is and then that clashes, so this is quite bifurcatory at this point, but yeah, that doesn't work either. So having that as a low end and having it as a high end, neither one works. I think there is a more elegant way to prove that. It certainly can't go any further because that would mean 4 in a row at the end of the train. And once it does that and it needs to get back to here, it can't wiggle anymore, I don't think. Yeah, there's no way of making it wiggle anymore without it touching itself orthogonally. So I think there is a more elegant proof of that. If you've spotted it and you're screaming at your screen right now, please do let me know in the comments. But I'm pretty confident that one way or another we can prove that it does come round the back of this 7, like this. Now obviously neither of these can be ends because they all 6 cells are sharing a box, so it's just not going to be an end like that. Alright, so if this 7 is a column clue, then this end needs to get straight away into here so that it can go up, which would mean forcing this end that way so that it doesn't clash. And if this 7 is a row clue, then this end has to come that way anyway. Either way, that comes out this way. Alright, now I promised the rest of the, I think I'm a lot more confident with the rest of the solution. So I guess we'll see how it goes, but it's rapidly approaching midnight, and I don't want to do too much more post-editing or practicing or anything like that. I want to get this video done, so it's going to be scrappy, but strap yourselves in, put me on 2 times speed, and we'll get through this Sudoku. It's worth it. It's good fun once you get into it. Alright, so now we've now got 3 train cells definitely in this row. So let's hypothesize that this is a row clue. If it's a row clue, then these are all dead. because we've finished our train cells for this particular row. That means it needs to escape up like that. The 7 would also be a column clue because it can't be a row clue anymore, so that would have to be in. That's all we need to do in terms of bifurcating by filling colours in. So this is all based on the premise that this is a row clue. Now this is the really fun thematic bit of the puzzle that I really like, and I wish I could exploit it some more, and I may look into kind of remaking this puzzle so that I do exploit this little trick a bit more. So if this is a row clue, that makes that a column clue. This one can't be a 7, so it can't be a column clue anymore, so it's got to be a row clue. And it has to be a different digit to that, so it can't be so this one can't be a row clue anymore, so it has to be a column clue. So this one has got to be a different digit to that, so it can't be a column clue anymore, so it has to be a row clue. Oh dear, this breaks. So we've kind of gone round in a spiral, which I think is really cool, to prove that this 3 can no longer be a row clue, because that would break this 2 because of this kind of spiral effect. So I really quite like that, and that disproves this 3 from being a row clue, so I'm going to paint it yellow for column. I know why yellow and column don't alliterate like row and red, but never mind. We're going with yellow for the column. And now because this 3 is a column clue, then the 2 can't be a column clue and the 4 can't be a column clue anymore, so they are both row clues, so let's paint them red. So this clue, whatever it is, well, it's not the digit 2, so it can't be a row clue anymore, so it must be a column clue. And because this is a column clue, then these, it can't be a 5 or a 3, so these 2 cannot be column clues, they must be row clues. So already we've done quite a lot of the disambiguating between row and column, which is always good fun. Alright, now, well, let's just quickly fill this in. What can this be? Well, the most we can fit into this column is 6. It's not going to be 6 because that would mean a kind of branch at this point, so it's actually a maximum of 5, but it's not 5 or 3 or 2, so it's 1 or 4. And we can't work out which one just yet. Okay, now let's hypothesize that this 7 is a column clue. If it's a column clue, then that goes in. And as we just did, that would force this to be a row clue, and that would be a column clue, and that would be a row clue. And therefore it would be done because we've just filled in 2 train cells here. So that would all be shut off. And now the question becomes, can we finish off the train in this kind of cave that we've just formed for ourselves here without the last 4 cells seeing each other? And the answer is a unanimous no. Well, we can without the last 4 cells seeing each other, like that works, but then there's too many clashes going on over here. We could make this a 1, a 1 and a 2, and a 1 and a 3. No, that's not going to work, so it's got to be the high end, so maybe it's a a 9 and an 8 and a 7 and a 9, but that can't be a 7, and that can't. So that, yeah, that would be a 7 and a 9. Then those would add up to 50. It's not going to work. There's probably a more elegant way of proving that, but there's just no way that we're going to squeeze in an end to the train in this region. It's just not enough space without some kind of clash being caused. So that does not work. So that was all just based on the premise that the 7 is referring to the column, so it cannot be a column clue. It must be a row clue, red for row. So these must all be in. It must come round the back of the 3 because it can't, that's a clash. It must go down here, and it must go along here. And in fact, it must escape to at least here. I think there are a couple of different ways you can approach the next few steps. I actually showed this Sudoku, as I do with all of the Sudokus that I make. I showed this to my dad, and I think he got to this stage with a different method. It did a few different things before reaching this stage, and I think he went on a different path from this point onwards as well. But I'll go with what I like to do at this point in the solution, which is to count the number of cells we've got so far on the train. So there's 6 in this box, another 3 here, and another 6. So that makes 15 cells in total on the train so far. Good. So how many cells are there on the train in total? Well, we know there are 30 in total. That's one of the basic properties of the train that we discussed a long time ago in the video. I realise it's an extremely long video at this point. But yes, that was a long time ago, but we did conclude that there are 30 cells on this train. So we've got 15 of them already. We need another 3 in this row, 5 in this row, 2 in this row, and 4 in this row. 3 plus 5 plus 2 plus 4 is 14. So we need 14 train cells in that region, plus the 15 here, so we can only have another 1 somewhere else in the grid. Either maybe that one, or it's going to be, well, in this row, but we can actually never reach the top row because we don't have enough cells on the train. So we can blank that out already. Right, now what happened? The next bit was quite clever, and I'll just have to talk myself through it while I talk you through it. Oh, well, actually something quite simple we can do is look at this cell. We know that these aren't in because it doesn't touch itself orthogonally. Same with that. That's out as well. Yeah, that's all we can do for now. So now how many options do we have in this column? 1, 2, and we've already got 1, so a maximum of 3. That can't be 4 anymore, so that is a 1, and we've already got that 1, so those are dead. We can grey those out. Okay, so if this clue here refers to the row, then it must be 1, because we've already said there's 14 train cells in this region, and we've already got 15, so if either of these refer to the row, then they must be 1. And in that case, the 2, there must be 1 train cell up here, so we can't add any more here. So those would both be gone. And that's if that refers to the row. If it doesn't refer to the row, it refers to the column, which forces that to refer to the row. So either way, we end up with 2 train cells in this row. I'll just go through that one again because I wasn't quite convinced in my own head of that logic before I started it, but I am now. So if there is a train cell in this row, then that's all 30 train cells accounted for, so we can't add any more in this row. So those are both gone. Those are both grey cells. If alternatively well, we could still have a train cell in this row, but if this is a column clue and not a row clue, then it must mean that this too has to be a row clue, because we can't have 2 column clues in the same column. And we also can't have this clue being a 0, because 0 is not a valid digit in the Sudoku, so we can't have a row clue cluing that there are 0 train cells in this row. It's not going to work. So either way, there are definitely 2 train cells in this row. That doesn't say for certain that this is a row clue. It could be both. It could be both row and column, but we do know that there are 2, exactly 2 in this row because of that. Which means that there is actually now going to be 1 in this row as well. We just don't know if that is going to be a 1 row clue or that's going to be a 1 row clue, or if they're both going to be column clues. Either one of the 3 is possible. Alright, now that we've grayed those out, these both have to come out this way. Now let's have a look at this 3. Oh, in fact, let's have a look at this 3 clue. That's something we could have done a while ago. We've already got 6 train cells in the row, so there's no way that can be referring to the row. It must be referring to the column. Yes, right, let's have a look back at this 3. We've already got 1, so we need 2 of these 3 to be in. Is there any way we can reach that one? Well, if we do, we'll have to have come via that cell, which means that we'll have 2 train cells in this row. And we know we can't do that. We have a maximum of 1 train cell in this row, so that's not going to be in, which means these 2 both have to be in. And because it doesn't turn back on itself, that can't be in, and now this entire kind of cave is shut off, so they're all gone. This can't be 1 either, because that would mean a kind of branch. So this has to escape this way. Can it be? Can that be an end? Let's say it's a 9 and an 8, 9 and a 7, and then we've got a 15 and a 14, and also a 9 in the same box. Too much, not going to work. So it does have to continue to come out that way. And now, in fact, we've got 3 train cells in this column. So this is indeed confirmed as a row clue. This row has now got 3 train cells in it, so that is done. We can grey all of those out, and that one has to come out up here. Now, this 3 comes into play. We've already got 1, so 2 of those must be in. Can that one be in? Well, if it is, then we will have had to kind of go up here and back down again. You know what? That does seem a little bit possible. No, of course it doesn't, because then we'll have 4 in this column. So that's not going to work. It's not going to work to do something like that, because that breaks this too. I think there are a number of different ways that you can talk about how this isn't going to work, but it's just not going to work. To have this as a train cell, we can't reach it that way because that would break the 5, so we'd have to go up and back down again, which would put a lot of pressure on this 2. The 4 then would be under pressure of not being completed, so the only way to satisfy the 2 and the 4 and the 5 would be to do that, but that breaks the 3. Yeah, there's a little bit of kind of visualizing and kind of trial and error in this kind of Sudoku, but basically, yeah, we can say with confidence that that is not in. Can that one be in? Well, if it is, then there must be another one of these cells in. Either it goes up and back down, or it goes up and then kind of S bends across. So we'd need 2. We would get 2 cells in this row in the train, so that would be blocked off, which would mean that this 4 would need to be satisfied entirely on this side of the this kind of dividing line along the middle, and we'd also need 1 up here, and there's just no way that's going to happen, is there? It's just not going to happen. Not with satisfying this 5 as well. It's not going to work. So that's not in either. I don't feel like that's the most smooth, logical proof, but it's very late. I'm very tired. I'm hoping that you can just visualize that what I'm saying is correct enough. So we are left with only 2 more options for our 2 remaining train cells in this column. We've now got our only 1 allowed train cell in this row. We know that all of the others are accounted for, so those are all gone, which means this has to escape this way. And at this point, essentially we either go, well, we've got 2 of these 4 now, so we either have a third like this and it comes down like that, and we do that, or we can't have all 4 in there, can we? Well, then we'd end up finishing in there, which seems okay, but it breaks the 5. That's not going to work. So in order to satisfy the 5, we need either that. No, we do need that. Of course we need that one. We need that one, and then either that or that. So that one's out, and we're certainly not going to dip in and out of that cell. So it goes either there, and then to complete the 5 it needs to come out as far as there, or it goes like that, and then that does complete the 5, so that goes up, and in order to complete the 4 it goes across to there. So those are our options, and then we can quite clearly see that this option that I've got highlighted at the moment leaves the second carriage and the third carriage in this branch seeing each other, and that's not going to work. If this is the high end, then this would be a 9 and an 8, that would be fine. Then we'd have a 9 and a 7, and then 2 digits adding up to 15, and that's not possible in the same box as a 7, 9. So that is not the correct solution. It has to go this way. Yeah, a little bit of trial and error and visualization towards the end, but we do eventually end up with the correct train. And now maybe, just maybe, you can see why I called it Ash's training. Maybe? Can you? Maybe not? Okay, probably not. It's based on the complete coincidence, and I promise this is not something I tried to make happen. This was a coincidence. It looks a tiny bit like a map of Australia. Do you see that? Maybe? Go and look up what Australia looks like. It kind of got these 2 bumps at the bottom at either side, and then 2 sticky uppy bits at the top. Maybe. It's a bit tenuous, but hey, it's a phrase that makes sense. It's got the word training, the word train in it, and anyway, whatever. You're probably cringing. I'll get on with the rest of the solve. So, is this the high end or the low end? Well, this can't be a 1 or a 2, so that can't be a 1-2 pair. So it must be the high end. So that's an 8-9 pair. That's a 7-9 pair. That 8-9 tells us that that's a 7. That's, whoops, let's get on to numbers. That's a 7, that's a 9. That adds up to 15, but it can't be a 9 and 6, so it must be 7 and 8. That 7 tells us that that's a 7, that's an 8. Those two add up to 14, so it must be 5, 9, or 6, 8, but the 8 and 9 obviously can't go in there. Those add up to 13. We've got a few different options for that at the moment. Those add up to 12. And it can't be a 3 and a 9 because of the 3 there, and it can't be an 8 and a 4 because of the 8 and the 4 in the column. So it must be 7 and 5, and it must be this way round. That 7 and 5. That tells us that the 13 can't be 5 and 8 or 6 and 7, so it must be 9 and 4, which tells us that that's an 8 and that's a 6. These add up to 11. In fact, what have we got left in this box? It's a 1 and a 6. Can it be 1 and 10? No, of course it can't. It's 6 and 5. That tells us that's a 1. Those add up to 10. It can't be 3 and 7 or 4 and 6, so it's either 1 and 9 or 2 and 8. We haven't quite deciphered that, but we'll come back to it. In fact, let's just skip the rest of the train and go to the other end. That's a 1 or 2 to add up to 3. That adds up to 4, so it's a 1, 3, so that tells us that's a 2 and that's a 1. And what that tells us now actually is that these can't be referring to the row, because if they were referring to the row, then the digit in the clue would be a 1 to describe that there is one train cell in this row. So these are not row clues anymore, they must be column clues. So this tells us that there are 1, 2, 3, 4 clues in the 4 train cells in the column, so that's a 4. And this is 1, 2, 3 in the column, so that's a 3. Okay, carrying on. Those add up to 5, but they don't have a 4 in them, so they must be 2 and 3, and that 2 tells us which way round. That 3 now tells us that the 3 and the 1 are that way round. This must be a 6, and it can't have a 2 in it, so it must be 5 and 1, and that 5 tells us which way round. These add up to 7, and they can't have 1 or 5 in, so they must be 3 and 4, and that 3 tells us which way round, which then tells us that the 4 and the 9 is that way round, which then tells us that this can't be a 1, 9 anymore, so it must be a 2, 8, and that 2 tells us which way round. I'll breathe at some point, I promise. This 9 can't be 3 and 6, or 4 and 5, or 7 and 2, so it must be 8 and 1, and it must be that way round because of that 8. This 8 can't be 3 and 5, or 7 and 1, so it must be 2 and 6, and that 2 tells us which way round. These now have to be 5 and 9 in some order. These have to be 1 and 9. These have to be 4, 6 and 7. This is all basically just normal Sudoku at this point. That's not a 7. This is 6, 7, 8, 9. We need a 4 in here. Not quite going to get it just yet. Right, okay, where do we look now? 1 and a 1 there, that puts a 1 here. This is 3 over here, and a 4 and a 5. A 5 there and a 4 there. What do we need in here? We need a 2 to go there. We also need a 4, 6, 8 and 9. But that's not a 6. That's not an 8 or 9. And that's not a 4. Okay, I think that's all we can do for now. And this is actually 4, 8 and 9 as well. But that's not a 4. Is that all we can do for that? Blimey. This is 4, 6, 7, 8, 9. But that's not 7, 8, 9. Let's just call that a 4, 6. Do we want to write that in? I suppose that's 6, 7, 8, 9, isn't it? Okay, that's 6, 7, 8, 9. But it's not an 8 because of that. Oh, and that's not an 8 because of that. Okay, in fact, what do we... Let's look somewhere else. Let's look at this column. We need a 3, 4 and 6. That's all, isn't it? And the 3 can't go there, and so it must go there. So that's a 4 or 6, and that tells us that it's a 6. So that's a 4, so that's a 6, 7 pair now. But there's definitely a 6 in there or there. So that's a 7, that's a 6. Now, what do we do? This has got to be the same as whatever that is, hasn't it? Oh, there's an 8 there. That's not an 8 then. So this is a 4, 6, 9 triple, effectively, which means that has to be the 8, that has to be the 9. So that's no longer an 8, which means there's an 8 there or there, and that 8 tells us where it is, of course. I feel like there's more we can do here. 4, yeah, 6, 7, 9. Probably more we can do, but we'll leave it for now. Let's just look over here. No, let's look over here. We need 4, 5, 7 and 8, but the 5 isn't here, so it's there. The 4 isn't there or there, so it's there. So that's a 7, 8 pair. What do we need in here? 1, 2 and 7, but the 1 goes here, the 2 goes there because of that, so that's the 7. This is 5, 6, 8 and 9. That's a 5, 8 pair, but the 5 tells us which way round. And this is 6 and 9, and that 6 tells us which way round. That 7 now resolves that for us. That's not 7, 8 or 9, so it's 6. That's not 7 or 9, so it's 8. That's a 7, 9 pair, which doesn't seem resolved at the moment. Let's see what happens over here. We need a 2, 5, 7 and 9. The 5 can't go there, so that's the 5. That puts a 9 there and a 5 there. That's now not a 9. That's not a 9 either, so that's a 4, 9, 4, 6, 6, 7, 9, 7, 9, and what do we need? 2. And there we go. That is how to solve Ash's training. Hopefully you enjoyed that. Yeah, a few slightly scrappy visualizing moments in there. I think it's a good puzzle. I'm not very experienced at the whole snake puzzles, where you have to use kind of row and column clues to decipher where a snake goes. There are a lot of those types of puzzles out there, so there is probably much more elegant, smooth logic that I'm just missing because I'm not very experienced at that kind of thing. So hopefully some of the more clumsy moments in the solution you just witnessed can be smoothed out by a better solver. If you have any specific points you'd like to raise, obviously please do let me know about a more smooth solution at any particular point in the solve. This is exactly the same rules as the one we just had. It's draw a train, and these clues indicate how many train cells there are in either the column or the row, or both. But as long as one of the column or row is satisfied. You know what? I explained the rules about 20 times at the beginning of the video. You don't need it again. So yes, I will come back to this one and this one at a later date at some point. I'm not going to make any promises about exactly when that will be, but they are out in the public domain now for you to have a go at. If you do have a go and you would like specific help with this one, or indeed this one, if you want to continue this but you get stuck at some point beyond what I've already spoken through, then do give me a private message. That's fine, or leave your comment in the comments below. Why not? That's always good for the algorithm. So yeah, do what you like. Do let me know if you have a go at any of these and you get stuck. But yes, at some point, probably in the next few weeks, I will be posting videos for these as well. Thank you very much for watching this mammoth video. I realise it's a very long one, but I really am excited about this rule set. I think it's an approachable one because it's fairly easy to understand. There are lots of different variants. I'm sure there are lots of other ways that you could clue where the train goes, not just the neighbours idea and the rows and columns idea. I'm sure we could have clues outside the grid, for example, saying how many train cells are in each row and column, or how many different stretches of train there are in a row or column. So, for example, if the train goes like that, then we might have a clue outside the grid just here saying 3, because there are 3 distinct stretches of the train. Maybe that's a variant that has some potential. So I think the potential of this rule set is more in how you clue the train cells rather than the train itself, because like I said at the beginning of the video, it's so restricted towards the end of each train that it's actually really difficult to find a legitimate train in the first place. And in fact, pretty much every time I've found one, I've just locked onto that, because it's quite rare that I actually find a legitimate setting of the train itself. So I just lock onto that and try and turn it into a viable Sudoku. But yeah, it's an interesting rule set. And yeah, once you do crack where the train is, it does become very easy to fill in a lot of digits very quickly, and it quickly becomes just normal Sudoku. So if that's the way that you enjoy finishing puzzles, where the cryptic element just melts away halfway through and it just becomes normal, then this is absolutely a rule set for you. If you like having the cryptic stuff stay right to the end and be required to distinguish between a couple of different things right up to the end, then maybe this rule set isn't for you. But I don't know. Thank you for giving it a go. Anyway, thank you again so much for watching all the way through this video, or for skimming through this video. Please do like and subscribe for more of this kind of content. Have a lovely weekend, rest of your week, and I will come back with more Sudokus in the next few weeks. Bye for now.